There's a lot of slick machine tool vending systems out there. Looks like it's one of those that's up there. What's special about this system?
This system has been in development from YMT Technologies for the last probably 10 to 12 years. Obviously, this has been designed with the thought, in fact, that this is a robot capacity 12. The robot capacity 12 is a 12 kg robot arm. We also have an RC25 and an RC35.
And it's about to do with the kind of payload size?
Yeah, so it's the payload of the FANUC robot. Our FANUC relationship with FANUC develops over the last probably 18 months, where we've been constantly developing this product to do as many different applications in CNC machine tending as possible. So as you can see, this one is robot capacity 12 kg. It's was ideal because of the capacity of the machine tool, and realistically, the 12 kgs is enough to pick up a small vise, self-centering 5-axis vise, and a smallish component.
Yeah, so perfect. And first of all, before we talk about the exact configuration of the system here, why do you work with FANUC?
FANUC typically are probably the most reliable robots, and we know that we have the support there from FANUC UK. We've done an awful lot of development over the last few months with FANUC, with this particular application, and with other applications with FANUC's hand and their support in the UK.
Perfect. And could you talk me through exactly the configuration? We've got a number of pallets here. I mean, how many? How does it work? We've got these self-centering vices.
So we have, in this particular robot, we've got 49 positions.
Can we open the door now that the robot's stopped?
So I can do that.
Okay, so we've had a look inside the door. Look at it, you've got 49 pallets?
So, yeah, 49 positions. Each robot can be different depending on the customer's what they would like, how many positions that they need. This particular one has 49 positions. Each position can have a completely different component in there. Anything you can put into a normal 5-axis self-centering vise, you can put on each different position here, 1 to 49.
Brilliant. What I find really interesting about this is you actually set up different kinds of components. So you've got a long, thin one. These are all a block, but just different orientations. And actually what you do is you would lock in your component into the vise here when you're setting it up. And the robot picks up the vise rather than the part. So you know the state in which your component is going to be machined when you lock it in.
It's absolutely no different than if you would have put a billet into a self-centering vise and then load it into the machine. This is no different whatsoever. The robot arm will do the lifting. It will do the loading into the machine for you. And the machine, as you say, will literally just do exactly what it would usually do as if someone were stood in front of the machine.
Yep, so it's perfect for doing 49 of the same component, but also perfect for doing 49 completely different components.
Yeah, so this could do 49 completely different components. The beauty of it and the ease of it is that the software that we've developed over the last kind of 18 to 24 months means that you could have 49 completely different programs, 49 completely different size billets within the unit, within the RC12. Each pallet position has been assigned a program number. That program number will just be called by the machine tool as and when it's finished the last component.
Yeah, and let's look at the software here. So it's actually quite a simple system. What I find interesting, there's no turnover station, there's no up 10, 20, just doing up 10 or just doing up 20. Why have you chosen to just allow that?
I think where we've been involved in automation over the last 12 years, the idea with this was to keep it as simple as possible and to keep it as affordable as possible. So a lot of customers that we have the experience with, they just want to get the spindles running, keep the spindles running, keep the green lights on. When the last component finishes, take it out, put a new one in. Yep. We haven't added any of the fancy bits of software onto this yet.
So the software here is fairly standard, fairly simple to use, easy to understand?
It's absolutely straightforward to use.
Okay. So can we see what's happening on the screen?
Yeah, so all this is doing, this is just in a cycle. So it's literally running a demonstration. So if we want to stop.
Okay, fair enough.
So that's stopped now. If we wanted to change, it is running in a cycle. If we wanted to change the cycle, it would take a little bit more, probably out of my pay grade.
Okay, fair enough.
Going at the moment, but it really is a straightforward software solution.
Okay, brilliant. And let's move into the actual work holding solution here. So the robot's putting the 0-point vices into. Is this pneumatically actuated? This an automated 0-point system?
Yeah, so it's a pneumatically actuated Aroa chuck. It's a VPC 52 Aroa chuck. Again, reliability, support. That's what we look for when we're doing projects like this.
And what I find really interesting is because the component, you've locked in that vice, and you're using the 0-point system, it's going to be sitting into your Aroa chuck here repeatably. The only question you have when you're running this at 3 in the morning with chips blowing, coolant blowing is, let's hope that the bit that the robot clamps onto is free of chips. That's the only bit you need to make sure is free of air blast. There's no air blast on jaw, faces, or anything to make sure a component sits down. Yeah,
so with everything that we do, we try and make sure that we do everything properly. So when we were specifying this particular chuck, it does have 3 pneumatic connections. So one is for clamping, one is for unclamping, and then one is for air blast. So out of the 4 holes, receiver holes, where the vice pull studs go into, they actually blast out air from underneath as well to get rid of anything in that kind of like middle of the night run.
Consistency is the number one thing you've got to worry about when you're working with automation. You want to run lights out, and it's obviously these are throwing coolant everywhere, chips everywhere. What do you think is important about the fact that you've got a FANUC robot with your Tusker machine working with a FANUC robot drill?
Yeah, it's brilliant. This is a fantastic solution. As I've already said, it's a compact machine, it's a compact robot solution. FANUC control, FANUC robot, FANUC machine. Again, it just comes down to the support and the continuity of the products within an automated cell.
Absolutely. And Andy was saying this is plug and play when you've got a FANUC robot drill working with a FANUC robot. So really easy to load into your machine tool. Auto doors, I guess people need to retrofit machines. That's the only thing they need to do to their machine.
Yeah, so when we came up with the concept, we came up with the concept that this is not just for YMT Technologies machine tool. We can also retrofit these robots onto other people's machines. To do that, auto door is necessary. Yeah. The chuck is necessary. Air through the table or into the chuck is necessary. All these things that these days aren't really big deals.
So a few requirements to automate your machine tool. That's the RC12 Tuscan from YMT with the 25 kilo option as well. Wow, James, some people might not know, and I didn't actually know, this is actually what's inside your EV battery. It's loads of little cells. These guys need to get, I guess, assembled. You're hearing from Daneka. What do you guys do?
Yeah, so we deliver manufacturing solutions to the automotive aerospace industry for e-mobility batteries. So we deliver the whole manufacturing concept and solution from start to finish, from logistics in to the finished product out. So working with people like Shunk and Scientech Systems who are behind us to deliver automation solutions into this market. So one of the big problems in the industry at the moment is scaling up of batteries. So you've got the unfortunate circumstances of Arrival, British Volt and Volta, where unfortunately they couldn't scale their manufacturing process. So what we're here to do is help customers grow and really deliver the value of their product into their battery solutions. So with Factory in a Box, what we offer is a complete service from you come to us, you need a system, we will deliver that system. So we're able to deliver for one of our customers an extra €6 million in net profit. We was also able to reduce the return on investment by 40% and increase production capacity by 170%. Now that's a customer who was already making batteries. Imagine what we can do with people who aren't making batteries. So with the expertise of Daneka from designing battery systems, we're able to deliver the knowledge and the know-how of what goes into the batteries, change that into a bit of design for manufacture and deliver the right level of automation that fits the customer's requirements, basically.
Sounds like you've got some real special sauce in there in Daneka. We'll talk about how you have that in a little bit. But first of all, why is it hard to assemble these? Why are your customers struggling to do it themselves?
So in the industry at the moment, there's a lot of really good integrators who can do camshafts and crankshafts, but there's always some nuance in e-mobility. You know, we're talking with much smaller products, you know, looking at sort of these cylindrical cells and handling these cylindrical cells. They're electrically charged, so you've got to have different isolation rules in there. And you know, placing these with the tolerances into something that's quite well machined is quite a challenge. So
why is that a challenge?
They're quite hard to pick up, they're quite hard to place accurately, and there's lots of intricacies in how we get them into the pack. And also, as you can see, they're really quite tightly placed in there so we can get the energy density. So working with Shunk and getting the best-in-class gripping solutions, we're able to pick up these battery cells and place them and get the energy density in the packs that's needed. Wow.
So the more you improve the actual automation system, the grippers from Shunk here, the better range the end car's going to have.
Absolutely, absolutely. And it means that we can also design in the automation at the start. So rather than being a typical OEM where they will design a battery pack and then think about the automation after, we bring them all together. The automation and DFM is done at the start, so we can deliver better solutions to our customers.
And when you're designing something like this, like you say, kind of maintenance, automation, how you manufacture it, the way it works, these are all very interconnected problems. They all have to be done at once, and it's kind of impossible. You have to iterate through every single sector. Let's talk about your special sauce now. What makes Daneka special? How can you do this?
So our founding members are some of the most have some of the most experience in the lithium-ion EV market. We're very proficient in design.
You're the best in the industry, then, in your opinion, obviously.
Yeah. Don't catch me out. But yeah, so we're from the origins of lithium-ion batteries. We understand the technology. So being able to understand what goes inside a battery, how the battery works, we're able to take that into the manufacturing and all the testing around it. So we're able to say, we know why we do this, and because we know why this is like this, we will do this.
You were there when the first design decisions were being made in this very brand new sector, still very new sector.
Absolutely. And we were able to deliver best-in-class batteries. Absolutely. You know, first high-performance sports SUV batteries from a UK OEM. We were the team behind that. And then going into hypercar batteries, aerospace batteries for a company called Vertical Aerospace. We were the first people in the UK to put batteries in an eVTOL. You know, we delivered that for Vertical Aerospace. We made the batteries for Vertical Aerospace. And because we know how they're made and how they're designed, we was able to do that flawlessly. Yeah.
You weren't just stuck in automotive, you moved into aerospace as well. It's an amazing story. Now let's talk about exactly how you set out the kind of factory layout. What do you do? Which solutions do you pick?
So it really depends on the customer's need. Automotive aerospace, it can be even grid storage. It depends on what the customer's manufacturing presence is already. So working with the guys at Scientech, we're able to deliver solutions that work for our customer, but they're always like a bespoke design. There's no one of these machines out there. So we start logistics in, all the process engineering, all the manufacturing engineering that is required to make the process work. We work with Scientech to deliver the equipment, and then we integrate the solution as the whole entity into the business. So
Seems they do all the hard work.
depends who you're asking. If you ask Tony over here, then he'll say he's doing all the
We're
hard
going
work.
to talk to Tony in a minute.
Yeah, I could imagine. But yeah, so we work together collaboratively, and this is why we work with Scientech, especially with Shunk as well, FANUC Robotics. We only work with these guys. It's always a collaboration. We've got a problem at the moment in UK manufacturing. We've got a problem in energy security and in the environment. There's not one company in the world that's going to fix all the problems. So we have to work together, and this is why we work with the people who we work with.
Absolutely fascinating, James. Thank you very much. We're going to talk to Tony now from Scientech. Exactly. Well, some might say he does all the work, some might say these guys do. It's a collaboration, though, Tony.
Yeah.
What do you do with Danica?
Just really would like to point out that it is us that do all the hard work.
Of course. James can't talk back now, I'm afraid. He's off camera.
Oh, he's got no chance to answer that as well. What do we do? Well, as James explained, we're in a big sphere of automation. Danica specialise in the EV market. New market sort of really came forward sort of 5 years on and is growing and growing and growing. We've been around, got a big heritage in automation. Understand robotics, worked with FANUC for many years, Shunk on gripper systems, and build lots of automation for lots of different sectors, aerospace, etc., and the likes. Excuse me. Working with Danica, it's a new market for us, or was a new market for the last 5 years. But what we've managed to bring is our expertise of automation and understanding laser systems, and having to refine those then for a completely different market. So a lot of principles of automation are the same, whether it's something for the nuclear, something for the aerospace, something for the automotive. The principles are basically the same, but you refine what we're doing.
So you can use that 40 years of heritage in this brand new sector.
That's exactly it, yeah. So we're bringing things that maybe we've learned from the nuclear sector that we're going to bring into the EV market, things that we may have learned in the aerospace sector as well.
There must be some new problems to solve, though.
There is. I mean, the main problem within this, picking and placing and things like that.
Which is what we're showing off here.
Okay, yeah, which is what we just did. This is just really a real basic demo. Picking and placing, nice and easy. The difficult bit with battery manufacturing, a lot of the automation we're seeing is welding. So we have a battery, a typical C-cell battery, very thin material, stainless steel. We have a buzz bar that we have to put across all the batteries to connect them together, and we have to laser weld through this onto here. So we're laser welding through a thick piece of aluminium onto a thick piece of stainless steel. Wow. Totally the opposite way around to you want to weld things. Normally you'd want to weld through something thin onto something thick. So getting the penetration depth of the laser through here.
You don't want to go into the chemicals and all the whatever's inside the battery.
What you do not want to do is laser weld through the battery into the lithium ion, else we're just going to have thermal runaway issues and that's
when you see some stuff you see on YouTube.
Yeah, you do. You see some stuff on YouTube. Yeah.
Happening to these cars.
Yeah. Again, very rare that actually an electric car will set on fire. It's just it sees the news. But in the manufacturing process, there is more of a risk because we are dealing with the raw elements.
Yeah, what I find interesting is some people, yesterday I can't remember who we were talking to, but we were talking about because this is kind of a slightly less well-defined production process compared to making a crankshaft people have done for tens and tens of years, because it's still not quite locked down. You're still trying to make this in high volume, but actually there needs to be a lot more inspection, it's a much more dynamic production process.
Yeah, so on the welding side, a lot of inline inspection. We have to really make sure that we're hitting the weld in the right place, so we'll have a lot of vision systems on there. I think, on the
Is some kind of inspection happening here as well?
We're just doing we're just simulating some electrical tests, but on the production systems.
Yeah, it keeps going green. Surely it's not going to go green 100% of the time in real life.
Fail the odd one. But again, if we look at this photo here, this is actually the type of laser head we put on, and all this is to do with sensing and vision systems and capability. So we have to make sure we're welding in the right place. We want to monitor the depth of the weld while we're doing it, and everything's all about collecting data, in-process monitoring, because again, we could be looking at 10,000 of those in a car. If one of those welds is wrong, the car's not going to work.
You might see those videos.
It won't be very exciting, the car just won't go. We do need to,
Brilliant. Thank you very much, Tony. Absolutely fascinating. That's Scientech working in collaboration with Danica and Shunk for best-in-class battery EV manufacture. I wish we could stay here longer, but we've got to keep going. That's been the FANUC Open House live stream. right now is the national finals of a WorldSkills competition. I'm here with Daniel. And FANUC's been working with WorldSkills for a long time.
Yes, 4 years now.
Yeah. Well, what is WorldSkills?
So WorldSkills is essentially a competition for any skills in the industry. It goes from hair and beauty to robotics, like you can see here. At the minute, these guys have a task to assemble these Mandekit cylinders here. The 3D camera will see the parts in. And
there's a camera up here.
Yes, so this camera here, supplied to us by Rockwell Automation. The parts will be took through the system bit by bit, assembled, inspected, sealed with a whiteboard marker, unfortunately.
Yeah, so they're sealed, as in they're just drawing a line around it?
Yes, yeah, it's just to replicate a seal as you would a part. So the idea is, once they're sealed, a barcode scanner will inspect the part with a QR code, and then these guys will have to put those parts into a pass or fail location on the SAM.
Sounds pretty complicated.
Yeah, I think it is actually. I think it's quite a challenging one.
Daniel's thinking I could do it in 5 minutes.
Oh, I don't know about that. Compared to the other years, yeah, I'd say it's probably the most complicated one we've had. Obviously, with the involvement of the pneumatics and stuff like that. So
wow.
And a layer to it, I'd say. Yeah.
Fantastic. And this is the national final, so the people here they've been through a lot already, haven't they?
Yes. So they would have come in on the initial starter phase, then the qualifiers, and then like we are here with the final. So. Yeah, everyone looks very excited, as you can see.
Yeah, there's a lot of pressure here, guys. They've been doing this for a day. They've got today, and they've also got tomorrow as well, which is Thursday.
Yes, tomorrow. Tomorrow's the last day. But I'm hoping today all the programming will kind of be coming along. Then tomorrow, tidying up in their extension task, which is to replicate this on RoboGuide, our simulation software.
Brilliant. So let's find out how one of them's getting on, and we'll see. Sorry, hello, how are you doing?
I'm not too bad, to be honest.
Brilliant. What's your name?
My name's George.
George, how are you getting on, George, and your partner as well?
It feels like it's going pretty well so far. I can't lie. My priority at the moment is documentation. My partner Jack, he's focusing on the robot, so I'm feeling pretty good about it, to be honest with you.
Sounds good. What's the journey like been so far?
It's been stressful, to be honest with you, but you're going to be stressed during these final competitions. But
I bet you've come a long way, and it's a lot of pressure now. You've got to keep going hard.
Oh, yeah, I'm in it to win it, to be honest with you. So I'm feeling the pressure now.
Okay, good luck, George, and everybody else as well. Even though George didn't win it, I love it. Thank you very much, George. Yeah, it looks like there's a lot of pressure. 3 days to get the whole assembly done. Yes. All this drawing, the pen sealing as well. It's definitely a serious project. But what do you think is the general benefit for young people to be doing challenges like this, Daniel?
Ultimately, it's to bring them into industry. And, you know, like those guys said, it's been very stressful and not all things go smoothly, which you would get in a normal work environment every day. So I think things like that are really important to grasp and, you know, recognise. So, yeah, it's...
Absolutely. And if you look at the components, I mean, these are kind of 3D printed plastic parts they'd be assembling, but this is it's representative on a small scale of what you might actually see in your first day as a robotic automation engineer.
Yeah, absolutely, yeah. You know, the most important things is to realise how, you know, your inputs and outputs work and, you know, link up to your robot. It's all just logic, really, but you know, you're kind of ignoring what's in there. It's just how it all comes together, if that makes sense.
Yeah, divide it into different components, get each component working.
Yeah, absolutely, yeah.
Brilliant. And what's FANUC's role been over the past 4 years working with WorldSkills? How have you supported each other?
Well, you know, I think FANUC and WorldSkills have a very close relationship. You know, we supply the kit for WorldSkills.
Yeah, and what are these boxes? So these are actually like educational boxes used not just for WorldSkills, but in general as well.
Yeah, these are education package. I believe FANUC don't make a profit on them as well, specifically for...
Really?
Yeah, specifically for education. So that's a nice thing on FANUC's behalf as well. Yeah, so all these come with a ER4 IA robot, your controller and your normal industrial teach pendant, which you would see on any robot, no matter how big or small they are.
Yeah, so FANUC don't make a profit on it. You can see they've actually got the proper industrial control system, industrial pendant, and a decent-looking robot as well.
Yeah, they're all right. Yeah, they do the job for these little cells. But like you say,
yeah, brilliant. So I've got these guys are working hard. They've got, I guess, once the national finals happens. What happens next?
After the finals, an awards ceremony will be held Friday in Manchester where we'll reveal the winners. And it's not just for engineering, it's for all the skills as well. So you're looking at a few hundred people in the theatre.
Sounds like quite a big event. Are you invited?
I am, yeah.
Whoa, that's why he's looking smiley. Getting you suited and booted.
Yeah, well, we could say that, yeah.
The national finals happening in Manchester on Friday. And that's FANUC working together with WorldSkills, but also FANUC investing in education all the time. Wow, we've got a beautiful automation system here in the corner of the FANUC Open House. And so we're looking at a Lynx machine here. Now, this is a good foundation to build an automation system on. Why is that?
Well, with an automation system and with this machine, it's a fast production machine, so you get a lot of production. But with an automation system, you can run it 24/7, and you don't need somebody to man the machine, and they take breaks and stuff like that. So with a robot, it's continuous, and you just go 24/7.
Absolutely, and thankfully right now they've paused the production, the 24/7 production for us right now. So if you follow me, let's go have a quick look at the machine. This is a fairly standard Lynx lathe, but we've got two spindles, main spindle, sub spindle, one turret. Now, on a machine like this, I guess you're going to be making components in one hit, probably, aren't you?
Yeah, you usually do first and second up, and there's also a Y-axis, so you can do a bit of milling on it as well.
Yep. So most components that would be kind of round with a few square features, you're probably able to do in one hit, which actually is probably nicely suited to an automation system like the one behind us. Now, what happens? Could you break down kind of the whole product? There's a lot going on here. Could you break down what we're looking at here, please?
Okay, so Mills manufactures a drawer system as one of their products, which is 5 drawers where the customer can put in raw material from the other side of the cell. And the robot will come in, open the drawer, take the raw material out, put it in the machine, finish the component, put it back in the drawer, and once one drawer is finished, the robot closes the drawer and opens the next drawer. So you could do multiple parts, or you could do one huge batch. And the advantage of this system is while the cell is running, the operator can be on the other side, taking out the finished parts and putting new billets in for the next run.
It's almost like a quintuple pallet changer, I guess, where you can access one side, or even you could access all 4 pallets while one is being pulled out by the robot. So a cute little kind of stud here that pulls the drawer out itself. It saves some actuation system on the drawer system. Now this is kind of like the standard product, and we've got some caging here. We've got some fabrications here that hold other parts as well. What are you trying to show with this part of the product?
Well, this part of the product is fully customizable. So if you've got parts that are really tall and they don't fit in the drawer, we could put an in and an out station, and we could customize to fit whatever material shape the customer has. And it's the same concept. It would take from one pallet, put it in the machine, and drop it in the finished pallet. We could also customize the fencing where we have loading bays, so you could get a forklift in to take heavier parts out and bring a new pallet in full of material. We've got a bin as well, so if a customer has parts that are finished and he just wants to drop them in a bin, they can be put in the bin, and then the bin can be rolled out, emptied, and rolled back into
You can imagine kind of really complicated casting parts that would be fitting on like a nice little interesting custom piece of work holding in here, just being dropped into a cage there. Now, obviously, kind of the meat of the business here is this FANUC robot. What kind of design decisions have you made in the location of the robot in relation to the drawers and kind of the reach of the robot? And I guess there's a lot more you could do with this. There's loads more space you could fit that this robot could reach.
Yeah, so when we design a cell, we've got to take into account the reach of the robot. Also, we can customize if there's anything extra that the customer wants within the reach of the robot. We can place it in the cell, and we can write software for the robot to go and do all those extra stuff. So it's very customizable, and you can do virtually anything.
Yeah, absolutely. We're going to be talking about the software in just a little bit. We're going to get a live demo of how to edit the programs and change over. And that's really quite important when you've got a machine tending system like this, because not many people have got 1,000 off of the same component. They might have 20 of this, 100 of that, 40 of this. It's really important to be able to change over quickly. How have you tried to make that easy?
Well, we've got a system that we do, and we can change the tool automatically within the process of the whole plant, or we can do it manually with a clip-on and a clip-off mechanism that we add to the robot. So we can just clip off the end effector, put another one in, and manually clip it back on. But sometimes the customer wants everything fully automized, so we can do that automatically as well.
I guess it's one of the problems with showing a demo is you're never going to show kind of exactly all the customization that a potential customer is going to need. But if you've got some projects potentially, some automation ideas at home, if you're watching, maybe you should check out this option from MTDCNC. Challenge them with what you need to do. You're talking about potentially post-processing stations.
Yes.
I was in like big deburring, cleaning stations, because there's a lot of space here the robot could also reach.
Like I said, if the robot can reach it, we'll customize the whole cell. So if the customer wants deburring or polishing or something like that, we can definitely do that as well and add it to the cell.
It's nice to know that there's also going to be a base that people know what they're buying. It's going to be the drawer system over here as well. We're going to be talking about a little bit a conveyor belt system as well, just for a little bit of in-process inspection. So thank you very much, Sam. We're going to move on to having a look at the software as well, which is really important. Here from MTDCNC, they've actually programmed the whole software system themselves, designed and made in the UK, which is brilliant. So you get a really good, strong machine from DN Solutions, and then the software here from it's James, right?
Yeah,
brilliant. Yeah. So James, you're going to be showing us the software demo, and for some people, I guess this is going to be most of what people deal with, the drawers and the software. The rest of that's all been designed, and hopefully the machine's going to be running sweet. So shows the software.
So basically, it's usability for customers, isn't it? The easier it is to use, the better. So people don't want to be sort of going through weeks and weeks of training to learn how to use a new piece of software. And it is really easy. It's like an app on your phone or anything like that. You know, it takes you through the process of creating a cycle. It's got a good graphical user interface. It's touch screen. You know, so for all the kids, it's easy to use.
Yep. Okay, fair enough. So I guess it's interesting. The robot's running right now, so you can't show us changing over the programs.
Not as such, no. We can run it out, and I could go through a quick example for you if you wanted to.
Yeah,
so
absolutely.
Look at a setup.
Yeah. So you've got different trays here, and you can see which components have been done.
Yeah, so we can see that obviously component number 1 is in the CNC. That's just been transferred over to the sub-spindle. Now we could select the component from the sub-spindle just by simply pressing that button. You can see the magnifying glass appears for inspection. Then what will happen is that component will be deposited on the inspection conveyor there, and then we can retrieve the component from this end. Wow. And then we can obviously take that to inspection or CMM or whatever you want it to do.
I love that it's such a visual interface as well. You can just click the button, you see this component number 1, whatever it is. You just click the button and then it comes out for inspection, which is fascinating. Also, you can see the actual program that's being run by the machine.
You can see the program that's being run from the machine and where you are in the program in the machine. You can also see what requests the robot's being had, like, you know, I want to load, I want to unload, I want to go to inspection, or, you know, all those different instructions that the robot are getting from the system between the software itself and the robot and the machine and everything, and it's all integrated and working together. So if you look now, what should happen is the component should be deposited on the...
we're a bit worried about tool wear right now. We've got a board that's really tight to tolerance. We're going to go and inspect it, make sure it's still in tolerance.
Yeah, that's it. And I'm going to drop that off to inspection, the guys in CMM.
So obviously this has been running for 36 hours already on the first tool, and hopefully we'll be getting the conveyor belt coming in.
So if I break the laser beam there, that sort of stops the component, and you can see the component come out through the conveyor.
Brilliant. So we've got the component coming in, and that is a closed cell. That's going to continue running.
Yeah.
We've managed to pull out kind of an ad hoc component there for inspection.
Yeah. And you can set an interval as well. So you can set an interval for inspection. So you can say every 10 or something like that. And also what you can do is you can send offset changes from the HMI directly to the CNC.
So you don't have to go and talk to the FANUC control. You can actually do it directly from the HMI here.
Yeah.
Okay, brilliant. So that's real software development done by MillCNC, all made in-house here in the UK on a really good foundation. The links from DN Solutions. That's some customizable automation. Make sure you check out MillCNC. we've got a really cool demo behind us. We're going to be talking about that in a little bit. First of all, who are Loop Technology? You've been going for a long time, but what do you do?
Yeah, so we're industrial automation specialists. We specialise in aerospace and defence programs and generally composite related applications. So high-value manufacturing is what we specialise in. So anything with high-value kinematic applications where we need vision systems, like the demo behind me, is generally where we sit. We do a lot of laser cleaning systems, machining systems using robot arms. We worked with FANUC for 4 years or 5 years or so. We really like using their robots because they are really pushing the aerospace industry. It's the value-added products that they provide really help us deliver cutting-edge projects, like I said behind me, what we're doing here.
Good, consistent robotics. Before we talk about the demo, you said a few words there, so we're talking high value. Yeah. What does high value mean? What kind of products?
So where you're looking at aerospace applications, like anything composite related. We do very large systems for high rate deposition of carbon fibre, so aeroplane wing skins.
This is like laying down the carbon fibre?
Correct, yeah, absolutely. So it's alternative to AFP, basically. So where we're...
What's AFP?
Automated tape laying. Or fibre placement, basically. So it has its place, but it's very slow in comparison to our technology. You're talking 20 to 30 kilos an hour. Our systems will be 200 to 300 kilos an hour, so it's significantly a giant step change in terms of the capability of the systems that we provide.
Sounds fascinating. I'm sure viewers would probably like to know how that works, actually. You said kinematics. So kinematics is the way the robot moves. Correct. What is special about these kinematic systems compared to a normal automation system?
We've done a lot of work with FANUC and their dual encoded systems, so the M800. So it's an extra accuracy, sort of step change in a standard robot. In this particular demo we've got here is basically using a vision system to automatically create a robot path.
So the vision system, sorry, just stop there. It's got like carbon fibre kind of effect camera up there.
Yeah, that's a PhotoNeo 3D aeroscan camera. The idea is that you can complete a CAM path without having any CAD data. So it's CAM without the CAD, basically.
I don't know what you mean.
So standard robot programming, you generally have the CAD file of the part, and you basically can offline generate the robot path using that within a robot scene or like a virtual scene. In this instance, we use the vision system to create a point cloud of the part, import it within our scene on the monitor you can see there.
That's amazing. Coming over, let's have a quick look. So if you can point at what we're looking at here as well.
Yeah, so you can see we've got our virtual scene here, and we've got the point cloud of the part, which is taken from our vision system above. We overlay our robot path. In this case, we're doing laser ablation, so sort of cleaning of the parts using a laser system, so removing paint, rust, and grease. We overlay a part, and the simulator will basically look at out-of-reach applications or issues with singularities or clashes, and we try and avoid those. It's a way of using, it's sort of an addition to what we currently do with our standard laser cleaning products. And
that's amazing. So laser cleaning, so whatever process you're doing at the end of this is really important. But what you're trying to do here is, without having the CAD file, you could put any surface on there. The camera looks at the surface, gets a point cloud, generates a toolpath. No programming required.
Correct. Yeah, absolutely. So it's really aimed at nuclear decommissioning. So where you've got lots of variation of parts, you have no CAD data, no drawings of the part, and we want to remove the contaminants of the parts. You can literally, the operator can put the part in. No experience in terms of no robot interaction.
No reverse engineering parts needed.
No.
That'd be a waste of process if you just reverse engineering the part just to write a toolpath and throw it away.
Yeah, absolutely. So then, it's minimal contact with the operator, no interaction in terms of robot programming. The system does it all for you.
That is absolutely fascinating. That's just one of the many projects that you've done here at Loop. You've got a few examples down here on these beautiful little sheets. Please explain, I guess, the varied projects that you've been doing.
Yeah, so like I said, we do standard laser cleaning parts. We've got an example here of like a 2m2 cell, use a standard robot. We use Robot Master to do offline programming, or use RealPath, which is what we're demoing here, which is an automatic path generation where we don't need any offline programming. I mentioned before about the M800, so dual axis robot arms, so it's another higher quality robot application where we're machining composite parts. We use a 7-axis kit, we've got a tool changer.
And what are the advantages of robotic machining over kind of a standard composite machine?
Yeah, I mean, that's a good question. I mean, it's good value. You get a very large area of machining. A standard CNC is very expensive. This is relatively cheap for the size of area that we can cut. Obviously, it's nowhere near as accurate as a standard CNC, but it's certainly...
the elephant in the room.
Yeah, it is, absolutely. But it's extremely versatile. You can, because you've got the 6-axis of the robot and, the 7th-axis kit, we can, access a sort of a 2 by 2 by 1 meter kind of area. And
you've got some kind of you've got some induction heating of a pipe here as well.
Yeah, I mean that's a great application. That actually uses a cobot robot arm. And the reason for using a cobot is you can drag the robot and teach a path manually.
That is like a giant game of that game. What's it called?
Yeah, that's exactly what you have to do. And the application is perfect. It's really interesting. And the operators love it because it's a fun game as well.
Yeah, really fun game. I love that one. Brilliant. So, loads of interesting projects, all very bespoke for customers, but I guess you have kind of, in the 25 years of experience, you have kind of modules you can pull out from previous projects and experience that helps speed up new projects?
Yeah, absolutely. I mean, all of our composites-related applications, they're all iterations of a previous design. We always look to improve. We've invested heavily in our R&D department. Quite a lot of what we do is R&D, I suppose. But I think that's really important that we have to invest in the future because that's ultimately where we sit. We have to look at the best applications and improve go from there basically.
Thank you very much, Adam. That's 25 years of high value automation experience here at Loop Technology. Really cool automated metrology demo to show you just over there in a little bit. But first of all, I'm here with Nikki. Accretech, really big metrology company. Some people might not know much about them. Who are they?
So, Accretech, established 1949 in Japan, formerly known as Tokyo Sumitsu. Obviously, we're called Accretech. Accretech is the Western name. Like I say, we've been going since 1949. People commonly know us through our business partners of the past, but since a few years gone by, we set up a UK point for contact for the Western customers, including our head office Munich. From that time, we've gone from strength to strength and grown exponentially over the last few years to the point where we're expanding continuously.
Brilliant. That sounds pretty scary. Exponential growth is pretty huge. You've only got 2 products here, unfortunately, but you've got a massive portfolio in the wider world, haven't you?
Absolutely. So, well, the point of today is to bring a couple of products suitable for the FANUC audience. So, the portfolio in general, we cover everything from tooling run-out detection, dynamic balancing systems for grinders. We supply the majority of OEMs for the machines. So here we're looking at right now, we're looking at the RD10 tooling run-out detection system, which is just here. You see the control unit that connects to a typical robo drill. Now, this tool run-out detection system basically looks for vibrations in the tool when, for example, you've got swarf contamination in the tooling holder.
So you've got some kind of proximity sensor here that looks at the flange on the
Absolutely. So we've got a little sensor there. So basically, when the tool's inserted, if the coolant flush hasn't been successful, the tool could be slightly running out.
Spin the tool around like this.
Yeah. so in effect, the tool can do this basically. And if you're machining a hole, that hole could be slightly larger. So if you've got an engine block in production and your holes are slightly out of tolerance, this is not a good thing. And
it's not quite going to work, is it?
No, so the scrap levels could go up quite significantly. This system you can connect it via Ethernet and control many systems, as we have got in the field in the UK already. And basically process control and scrap reduction, so a lot of customers use this remotely so they can see what's happening in their tool and literally put a critical moment in if a tooling run out occurs, so they can stop production, change the tool, get it cleaned out, replace the tool if necessary.
And I guess automotive is a really good example here because they're doing real huge volumes. It might not be used by a job shop doing 1 or 2 parts a day,
Absolutely.
but high volume, you need to get that real 99.999% process control.
Absolutely. And that's the core aim for this product. But if you do have a single, very expensive component with multiple tool changes, and you are machining the likes of aluminium, etc., where the material is quite soft and sticky in compared to, say, Inconel, let's say, this becomes quite critical also in high-cost single components. And customers are realising this, and they're realising the cost savings also.
Yep. Tool run out is a real big issue with tool wear, with part quality, vibration even. But enough about tool wear, we've got a really cool demo here doing something that quite a lot of people actually, they're not doing yet in their machine shops.
No, so this is something else we wanted to demonstrate because it's not typically seen by the UK audience in particular. So stereotypically, we have here, just to go over, we have a FANUC cobot feeding a radial measurement machine. So this is metrology, the science of measurement. Our customers, the more discerning customers at the higher end of the market where their components are basically sub-micron, will use these radial form machines to check the form and geometry of the components. What we're looking here, you can measure the component in maybe, let's say, 10 mil in 2 points. But when you measure the component over 14,400 points, you might realise...
And that's around the whole diameter?
Yeah, absolutely. It will go round. And the beauty of this machine, this Roncon machine here, is that we can measure planes, bore cylindricity, coaxiality, perpendicularity of axis to a plane. The list goes on.
We're looking at, I mean, you mentioned off camera a lot of automotive examples like crankshafts and axial products.
We have iterations. This is just one machine of many in our surface form and geometry portfolio. This is a radial machine. We also do surface form and geometry. We have customers, for example, that will measure on a very different machine to this, but fundamentally the same functionality. We'll measure engine blocks, crankshafts. They'll look at surface finish of piston bores, measure the pistons, anything you can imagine, right down to silicon wafers, looking at node paths on our surface finish machines. We can check the form. So
that's some really small stuff.
Yeah, so it's proper nanometer stuff. So we're quite proud of these machines being, you know, some down in the nanometer, some sub-nanometer range if you've got deep enough pockets, right down to the crude 24/7 CNC production. But at the sub-micron range. So the point of us being here today at FANUC and being quite proud is showcasing what is stereotypically reserved for the standards room or an inspection room. Basically putting a collaborative robot offering a lights-out solution to something that is fundamentally an item that really hasn't been available before. So we've picked a machine that generally you would never see with a robot. But people would love to because it's a lot of time for the operator to be standing at the machine.
Completely. I mean, depending on the kind of components you're doing, some need to be inspected every single one, not just 1 in 10 and 1 in 100. If you need to inspect every single one, maybe it's a new contract, you've never had this kind of tightly toleranced component before, suddenly this thing becomes your bottleneck.
Absolutely. And that comes down to takt time. So obviously you look at takt time through a process. When you're measuring high quality, high precision components, quite a large part of the component tax time is actually the measurement and inspection, and the intermediate operation inspections that you have to carry out whilst mid-process. And it's quite common if you haven't got this kind of thing in process where an operator will walk away from a machine. So
Leave it idle.
Leave it idle. Rather than having a palletised system, we have some system where you palletise it, put it on, and then the flow's constantly running. And this is the key aspect, and this is what we want to demonstrate.
I'm going to ask a bit of a challenging question here. I hope that's okay. Sure. I'm interested. Some people will say, well, I've got on a first article inspection on a component, and I can't run any more of the batch until I've got this first article inspection finished. I mean, how do you solve that? Sounds like an unsolvable problem. How do you deal with that?
The trick is speed.
No, that's a tough one.
The trick is speed. So you have your systems pre-programmed ready. So our systems, although they're high-accuracy metrology pieces of equipment, they are full CNC capable. So you can have a program rewritten for separate operations. So the operator stroke programmer, which generally are in these style of products, could place it on, literally press the button, go and prepare his next piece. While he's preparing the next piece, he can walk back, see the good, no good, variation, offsets required. Then he's got his next part prepared whilst taking the other component straight back to the CNC machine, and he's good to go.
You need to shave off those times in between, because you can't run the machine while it's doing the first article inspection, but shaving those times in between is really important.
Yeah, every process is different, and there's always different amounts of time to shave off different places, but let's go for the big one.
Yeah, perfect. Let's try and shave some more time by using automation on CMM machines, all these really fantastic sub-micron and micron machines. Super accurate from Acritech. Thank you very much, Nikki. That's it, we're moving on. We've already covered a bigger robo shot with Joe. That was yesterday. But you had like some automation at the top here you saw, which was already fairly compact. But here there's some automation. I can't even see it.
Yeah, so yesterday that was our 7th axis top picking robot, designed mainly for clean rooms. Around here we can talk around in a minute. It's a little bit tricky to see as it's
Go and look at it a little bit later.
But we're here at our cap producing trial machine. So this is one of our molds that we have for trials with customers when they want to try our machine. They
like
want
an example component.
Yeah, a good example component. It's got relatively low complexity, so it's quite low risk. But it's a nice multi-cavity mold that we can get a high production cycle throughput.
Still some really nice movement happening in the mold just to release the caps, and then the robot comes in, which we'll have a look at later. This is kind of a standard medium-sized robo shot, standard servo electric, but there's a lot of actually cool little features in here, aren't there?
Yeah, so this is kind of a mid-range model for us. We work from 30 tons up to 500 tons. Yeah, they're quite compact, really low footprint, which is great for kind of smaller manufacturing outfits or clean rooms where you've got to maintain that small footprint. One of the things we want to show here is the fact that we can have a VNC controller for other ancillaries on our machinery.
What does VNC stand for?
I'm not entirely
sure. Oh, you don't know? That's okay, no problem. So VNC...
network controller, virtual network controller.
Virtual network controller.
Yes.
Okay, brilliant. Well remembered, right on live as well.
Yeah, no, it's the pressure of on live. So yeah, quite often, like for instance, the screen we're looking at here is the hot runner controller.
This is each a different runner or a different sensor.
This is a different sensor, different area of the tool, which is heated. So you can see here, it starts off cooler and gets hotter towards the end.
So this is running through the hot runner as it cools down, as it goes through the material and heats the other material up. The runner will cool down.
So yeah, it comes out the screw and barrel at a certain temperature, and then we want to maintain that heat through the tool. So that we get no cooling off material, so we can have less waste in production with a hot runner system.
That can damage your components, reduce part quality.
Yeah, you get kind of increased part quality, but you get faster cycle times and less waste.
I'm showing off my absolute lack of knowledge in plastic production here, unfortunately. So this is showing off kind of some extra sensors that are they manufactured by other people?
Yes, so the hot runner controllers can be anyone you use. You can pick, but we can integrate with pretty much anyone. Quite often, before the integration, you'd see kind of a box on the side with the hot runner controller here. Obviously, that's extra cost. We can have it all inbuilt now and all from the VNC screen, so you can control it, you can change things, you can alter it without having to go for a separate box on the side.
All integrated in one nice big screen on a FANUC control, which we absolutely love.
Yeah.
There's also another extra bit of control, a little addition in here as well. It's like a water controller.
Yeah, so not only is the hot runner controls, but kind of any ancillary equipment. So it could be the material feed system, or it could be, for instance, here, the temperature controllers for the water. So cooling the tool.
Brilliant. And that's, again, important for process control in sectors that need that. What are those sectors?
So mainly medical. I mean, certainly everyone has to control the water temperature and uses hot runner in any plastic molding, but certainly our application we aim for is that medical industry. And certainly for this application, it just makes it nice and slick in your molding shop. You've got no extra boxes, extra wire, dirty things, other things to control. It's all in one screen. You can stand here and access it all.
Nice, clean solution. We like that. Proper engineered solution. And obviously you get good process consistency with every FANUC product. Let's go around the back and look at the process automation. And as you said, it's a really small footprint for quite a big mold making. How many are we making? 6 at a time of these caps? Or
it's a 12 impression tool.
So 12 caps at a time.
So yeah, you can see from the tool actually it's quite small in the tie bars. Our 130-ton range has got quite a large tie bar spacing, so you could get quite a large tool in there, and probably could produce way more than 12 if I'm honest. And yeah, you can see on the side here, our 6-axis robot picking out. So unfortunately, we're slowly running out of material, so we've had to slow the process down so we don't run out of material by the end of the show.
You're slowing the robot down to make it pull it out a little bit slower.
So it's it's not producing at the highest speed possible.
So you're making too many parts too quickly, which is never normally a problem, is it?
No, not for a moulding shop, but unfortunately for our show.
They're shouting at the screen like, speed it up, speed it up!
But this is, again, a really nice automation solution from our partner Hi-Tech. As you can see, it's modular, so you can pretty much kind of slide it up to the side of the machine and integrate it with the right end-of-arm tooling to pick the parts. Yeah, really nice, clean solution for automation.
Cool. Again, a small compact size, just like the RoboShot, so they actually seem to work together quite well.
Yeah, I mean, you can see from here, compared to, say, a 3-axis Cartesian robot, which would be right out the side, really high. It's really low head height, and it's also, not sticking out the machine. At the side of the machine very far at all.
Yeah, brilliant. And one thing I find quite interesting is the robots seem to be kind of very small, compact next to the machinery. I've seen kind of big gantry-style loaders on runners. Yeah. They seem quite big and clunky. I mean, what is the difference between those styles of automation?
So that would be a 3-axis Cartesian robot on like a linear rail. They're good for certain applications. I mean, for like sprue picking and more basic stuff. They can be restricted by the molding cycle. With like modern machines, you can get really, really fast cycle molding.
You need a fast robot going in and out.
So you need
those linear rails that just can't achieve the speed.
Yeah, you need a fast robot going in, but also with the 6-axis, you can do additional features. As we saw yesterday with the one out there, you're not just picking from the tool, you're also placing, laser etching, and doing lots of different things.
As soon as you invest a little bit more and get the 6-axis, you'll have so much more freedom to and reach to achieve different processes.
Yeah, and like you said before, with that 3-axis, you'd be coming right out the side here. You'd have to have, again...
tall as well, aren't they?
Yeah, probably like 2 or 3 times the height of the machine again, just to get one in. And then if you're in a clean room environment, that's incredibly expensive to control and clean all that air above it. Whereas this, you're low height, low footprint.
Perfect for medical application.
Yeah, perfect.
Brilliant. So that's it. Good process control from FANUC, as always. Good good process automation in a tiny little compact space. Thank you very much, Joe.
No problem at all. Pleasure as always.
Sweet. Thank you for watching the live stream. That's been FANUC Open House Day 2.